An essential element of any etalon-based solar telescope system is the blocking filter. What does it do? What size do you need? Let's dive in and learn a bit more about this critical part of your solar telescope. A blocking filter is a vital component in a solar hydrogen alpha etalon-based telescope. Its primary function is to isolate the specific wavelength of light emitted by hydrogen alpha, which is 656.28 nanometers, while blocking all other wavelengths. This allows observers to see the sun's chromosphere, a layer of the solar atmosphere where H-alpha emissions are prominent. The etalon is the heart of an H-alpha telescope. It consists of two highly reflective optical surfaces separated by a precise distance. This creates an interference pattern which selectively transmits specific wavelengths of light. However, while the etalon transmits H-alpha, it also transmits other wavelengths that we need to block. The blocking filter is placed after the etalon in the optical path. It is designed to have a very narrow bandpass centered on the H-alpha wavelength. This means it only allows light within a very small range, around 656.28 nanometers, to pass through, effectively blocking all other wavelengths. Typical solar blocking filters have a bandpass of 2 to 8 angstroms. Blocking filters typically consist of multiple layers of dielectric materials that are deposited on a glass substrate. These layers are designed to reflect or transmit specific wavelengths of light through interference effects. The filter is carefully tuned to achieve the desired bandpass and high transmission at the H-alpha wavelength. In addition to its primary function, the blocking filter also plays a crucial role in safety. It blocks harmful UV and IR radiation that can damage the eyes. Sunlight enters the telescope and may pass through an energy rejection filter for telescopes larger than 110 millimeters of aperture, which blocks most of the sun's heat and light away from the hydrogen alpha wavelength. The remaining light enters the etalon, which selectively passes the H-alpha wavelength along with other unwanted wavelengths. If available, the light may then pass through a second etalon, which narrows the bandpass further. The light then passes through a blocking filter, which isolates the H-alpha wavelength by blocking all other wavelengths. The H-alpha light is then focused by the telescope's optics, creating an image of the sun's chromosphere. Coronado telescopes usually employed 5, 10, 15, and 30 millimeter blocking filters. Lunt Solar Systems provides blocking filters at 4, 5, 6, 12, 18, and 34 millimeters of aperture. The smallest one that is provided for a particular telescope will be fine for visual observing of the full solar disk with most eyepieces. Why might you need a larger blocking filter? You could need a larger blocking filter if you are using a very large aperture telescope, you are doing solar photography, not just visual, you're using a DSLR, or you're using binoviewers. Note that the long end of a blocking filter in a Lunt design aids in increasing focus travel. You should never use a blocking filter by itself to view the sun. That would not be safe. Smaller blocking filters are less expensive, but not lower quality. The size only affects how much area around the sun you can see without vignetting. There is no point in getting a larger blocking filter than you need. Blocking filters are typically included internally in the design of Daystar quarks, which is why these systems do not require a separate blocking filter. Blocking filters often include a blue glass filter. The blue glass will pass HA and block UV-IR. Due to its light filtering capabilities, blue glass can also help manage heat generated by intense light sources. Blue glass filters are subject to moisture degradation over time, but Lunt offers replacements for only $10. In summary, the blocking filter is an essential component of a solar H-alpha telescope. It works in conjunction with the etalon to isolate H-alpha wavelengths, allowing observers to safely view the sun's chromosphere with high contrast and detail. Hope this was helpful, and thanks for watching.